Alrighty, so let's look at some examples for one-dimensional kinematics problems. For our first example, let's say we have a bike moving at 20 meters per second, begins to slow down, with a constant acceleration of 2 meters per second squared. What is the bike's velocity after 3 seconds? Okay. Well, if we remember, one of the first things you want to do is, after you've read through the problem and you have kind of an idea of what's going on, write down what's given in the problem and what you're looking for. So I'm told a bike is moving at 20 meters per second. That means the initial velocity is 20 to the right, let's say. It slows down with a constant acceleration, acceleration of 2. Now I'm being told it slows down, so that means it's the opposite direction of the speed. If the velocity is to the right and I'm slowing down, then the acceleration is to the left. That's what slowing down means. You're accelerating in the negative direction. So when I write down my acceleration, because I'm slowing, I need to write it in a negative direction, negative 2. And I'll go ahead and write the units. What is the bike's velocity after 3 seconds? So I'm told the time we're looking at is 3 seconds, and I want to find the final velocity of the bike. All right. Next step I would do, given a general problem, is let's look at what equations are available to us. Well, we have x equals v naught t plus 1/2 at squared. Another equation we have is vf squared is v naught squared plus 2ax. And lastly, acceleration is change in velocity over time. All right, so all of this I've done. I haven't even thought about how to solve the problem yet. All I did was pick out information and write down the equations. This is all mindless. Nothing, no thought has gone into any of this yet. Now is when I start thinking. Say, okay, I have possible equations. I know what I'm looking for. I want to find final velocity. So how do I figure out which equation to use? Well, first, one thing when people are first looking into physics will probably want to do is say, well, let's use the second equation. Because the second equation says final velocity equals. So that must be the equation for final velocity. This is not true. I believe I said it in our lecture on the theory of one-dimensional kinematics, that all of these equations are equations for any of the variables, not just the one that's on the other side of the equal sign. Okay, remember, we have the power of algebra, which allows us to move variables around and manipulate these equations. So, for instance, the first equation, which says x equals blah, 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 that doesn't mean that equation is for x. You can use the equation to solve for x, but you could also use the equation to solve for v naught, or a, or t. It doesn't matter. So, best thing to do is to get that way of thinking out of your mind. If the equation says vf squared equals suff, that doesn't mean you must use that equation for vf. You might be able to use it, or you might not. The best way to go about figuring out which equation to use is to start asking yourself questions. Say, okay, what is it I'm looking for? And what do I have? Well, I'm looking for VF, so I start with the first equation. Can I use the first equation to solve for VF? I don't think so. And the reason I don't think so is because VF does not appear in the equation. So that equation has nothing to do with final velocity, thus I can't use it. So, no to him. Move on to the next equation. Can I use this equation to solve for VF? Yeah, there's a VF in the equation. Okay, that's good. Now I ask myself subsequent questions. Do I have every piece of information necessary to solve this equation? And what that means is, given I don't know VF, do I have every other variable? So I start looking. Do I have V naught? Yeah, 20. Do I have A? Yep, -2. Do I have X? No. This question didn't tell us about how far the bike went, what's his change in position, what's his displacement, none of that stuff. So I know nothing about the position of the bike. Thus, because I don't know VF and I also don't know X, there's too many unknowns to use the second equation. So he's gone. What about the third equation? Well, the way I've written it, it's not clear, but if you remember, I could rewrite it where I say explicitly what change in V means. Acceleration is final minus initial over time. Remember, change in velocity is final velocity minus initial velocity. So that's really what the equation looks like. So again, can I use this equation to solve for VF? Yes, there is a VF in the equation. Do I have every other variable? Let's see, do I have A? Yep, -2. Do I have V naught? Yep, I have 20. Do I have T? Yes, T is 3. All right. So I now know I can definitely use the third equation. It doesn't mean I have to. If I had more equations, there may be another equation I could use as well, and maybe one's easier than the other. But what I can say for sure is this is allowable. And since this is the only equation I have left for now, I must use it. So this is the equation I'm going to use. From here, you have your choice of how you want to go about doing this. Some people like to plug the numbers in immediately and then do the algebra. Other people like to do the algebra first and then plug the numbers in. Whichever way you want to do it is fine. I'll go ahead and do the algebra first and show you what that looks like. So I start with the equation. A is final minus initial over time. And I'm going to rewrite it. Or I should say, I'm not going to rewrite it. I'm going to manipulate it. I want to get VF by itself. How can I do that? Well, in order to get VF by itself, the first thing is there's a denominator. I have to get rid of this denominator. So I'm going to multiply by T. But if I do it to the right, I got to do it to the left as well. So now my equation is A times T equals VF minus V naught. Because remember, the T's cancel here. All right, now what can I do? Again, I still want VF by itself. Well, I'm subtracting V naught on the right, so if I add V naught to the right and I add V naught to the left, that cancels him, and so now I'm left with VF equals V naught plus AT. And now I have my equation. Now I can stick my numbers in. VF equals V naught, which is 20, plus A, -2, times T, which is 3. And what do I get? 20 plus, let's see, -2 times 3 is 6, so 20 minus 6 is 14 meters per second. Now, before I box the answer, I ask myself, does this make sense? I know I can't truly tell if this must be the right answer, but at least does it make sense? Well, I was moving at 20. I slowed down for some period of time, so obviously my velocity should be lower. And indeed, I got 14. My original velocity was 20. I'm moving slower than I was before, so that makes sense to me. I can box the answer. And that's how you solve one of these problems. That's the full step-by-step process. Every time I solve a problem in kinematics, this is how I do it. Now, sometimes I may skip a step. Sometimes I won't have to write all the equations because I just know which equation to use. But if you're a beginner or you're not extremely comfortable and you have hundreds and hundreds of problems practiced, this is what you should do. First step, this stuff on the left side, write down everything you know and what you're given, and what you're looking for, I should say. The next step, write down your equations. Then what you're going to do is use those two pieces of information to figure out which equation you should use, and then you do the math to solve the equation. How do you figure out which equation to use? You say, well, go down the list of all your equations and ask, does this equation have the thing I'm looking for in it? If it does, then you can move on to question 2. If it does not have the variable you're looking for, then you know you can't use it and you move on to the next equation. So the first equation didn't have a VF, so I had to automatically just move to the second equation. The second equation did have VF, so I asked myself the second question. The second question being, given VF is the thing I'm looking for, do I know all of the other variables that are in this equation? And in this case, I didn't, because I did not know X. Since I did not know X, there's too much stuff I don't know. This equation I'm not allowed to use. Or, at the very least, if I want to use the equation, I would have to figure out X first. Because that's going to come up sometimes. There will be some problems that as you get more complicated questions where you can't use any of the equations at first because you don't have everything you need. However, you do have the ability to calculate the things that you don't have. So if this were some other question and we went to the second equation and we tried to use it but we don't know X, but for whatever reason we also couldn't use equation 3, then we'd have to say, okay, well, how can I figure out what X is? And the problem would have to give you enough information to be able to figure it out. So you would calculate X first, and then once you have X, then you go back to the second equation and you say, now I can use it. Okay, so that's going to come up in the future. But for now, with these equations at the beginning, understand that if you're not given enough information, just move on to the next equation. One of the equations will be able to work. All right, what else? How about this? Let's ask this question. And I'm going to have to erase some of this, but let's ask the second question, which is, how long does it take for the bike to come to a stop? How long until the bike stops? Okay. Well, let me rewrite the stuff that's given and the stuff I'm looking for, because now that's different. So now what do I know? I start at 20, so V naught is still 20. I have an acceleration of slowing down, -2. Now I'm being told the bike is going to stop, so I know the final velocity is 0, and I want to know how long does this take. So now I have to review my equations again because I have different information now. So let me rewrite them really quick. Okay. So now I'm told, all right, I have V naught, I have VF, I have A, and I'm looking for T. Look at the first equation. Can I use the first equation to solve for T? Yes, there is T in this equation. Do I have all of the pieces of information for the equation? Do I have X? No, I still don't have X, so he's gone. Likewise, equation 2, I asked the question, can I solve it for T? No. Second equation doesn't even have T in it, so look, he's gone. Third equation, VF minus V naught over T. Can I solve this for T? Yes, T is in the equation. Do I know V naught? Yes. Do I know A? Yes. Do I know VF? Yes. All right. It just so happens I could again use the third equation here, but now to solve this new problem. So, acceleration equals VF minus V naught over T. This time I'm solving for T. All right, so how do I solve for T? Well, let's get T by itself. I don't like it being in a denominator, so I'm going to multiply by T on both sides. And I now have A times T is VF minus V naught. But again, I want T by itself, so I don't like the A sitting there. Since they're multiplied, I'll divide by A on both sides to get rid of them. So I get T is VF minus V naught over A. So 0, because I'm coming to a stop, that's the final velocity, minus 20, that's the initial velocity. Acceleration is negative 2. 0 minus 20 over negative 2, that's negative 20 over negative 2, which is 10. How long will it take for this bike to come to a stop with this acceleration? 10 seconds. And there you go. A different question. Same problem, same setup, but a different question. I have slightly different data I have to use. Looking at my equations, I ask the same questions. Figure out which equation I have to use, plug the numbers in, do my algebra, and I get my answer. So I hope that's fairly clear. Let's try another example. All right. A car starts from rest and accelerates at 5 meters per second squared for 3 seconds. How far does the car travel? And part B is what would be its final velocity? Okay. So, what's given in my problem? Car starts from rest. V naught equals 0. Accelerates at 5 meters per second. Acceleration is 5. And it does that for 3 seconds. Time is 3. How far does the car travel? What is x? What is its final velocity? What's vf? So there's all the data we know and what it is we're looking for. Next, write down my equations. X equals v naught t plus 1/2 at squared. Vf squared is v naught squared plus 2ax. And acceleration is final minus initial over time. There's my equations to use. All right, so let's look at part A. Part A says, Calculate the distance traveled. How far does the bike or the car go? All right, so let's look at the first equation. Can I use the first equation to solve for x? Well, first of all, x is in the equation, so that's allowable. Second question, do I have all of the other pieces of information? Let's see, I need v naught. I'm given v naught, that's 0. I need a t. The time is 3 seconds, that's given. I need an acceleration. Acceleration is 5. All right, I have everything I need. I can use the first equation to solve this. I can look at the second equation if I want. Let's see if the second equation is usable. Vf squared is v naught squared plus 2ax. That's got an x in it. Good. Vf. Do I have Vf? No. Vf is something I'm looking for. So can't use the second. And we can look at the third and say the same thing. In fact, we could say even more. The third equation doesn't even have x in it. So I can't use the third equation either. So I'm stuck. I have to use the first equation. All right, fine. Let's use it then. X equals v naught t plus 1/2 a t squared. It's already manipulated to find x, so all I have to do is plug the numbers in. V naught is 0 times t is 3 plus 1/2. Acceleration is 5, 3 squared. All right, 0 times 3, that's just 0, plus 1/2, 5 times 3 squared. All right, 3 squared is 9. 9 times 5 is 45. 45 divided by 2 is 22.5. So, how far does this car go? 22.5 meters. So part A is done. Now let's look at part B. Part B says, what is the final velocity? Okay. We go back to the top, look at the equations, see which equation we can use. Can I use the first equation? There's no VF in it, so no. I can't use the first. All right, what about the second equation? Do I have everything for that one? Let's see. I'm looking for VF, so that's good. Do I know V naught? Yep. Do I know A? That's 5. Do I know X? I just solved for X, so I know it. Okay. So I can use the second equation. What about the third, just for fun? Can we use the third? It does have VF. Do I know A? Yes. Do I know V naught? Yes. Do I know T? Yes. All right, so here we have two different equations we're allowed to use. And it doesn't matter which one we use. They're both valid equations, and they will both work. Now, let's see which one is easier. If I were to look at this, I would say, okay, the first one, the second equation here, VF squared, I would have to take a square root at some point. And also, I'm using my answer from part A to solve it. Okay, that's okay. If I'm confident that I got part A correct, then it shouldn't be a problem. However, if I made a mistake in calculating the position, part A, then I know my answer to part B is going to be wrong because I'm using wrong information to solve it. Now, I'll go ahead and do it because I'm fairly sure this is the right answer. So I'll show how to solve it using this equation. VF squared is V naught squared plus 2AX. Okay, so VF squared is 0 plus 2 times 5 times 22.5. So this says VF is the square root, because I need to get rid of the VF squared, so I square root both sides. 2 times 5 times 22.5 is 225. And the square root of 225 is 15. All right. Now, I'll go ahead and solve it with the other equation, and we can see if the answers match. Of course, you don't have to do this, but maybe some people would have used the third equation, some people would have used the second equation, so I'll give both. Let's say I use the third equation. That was A is VF minus V naught over T. I want to solve this for VF, so I bring T to the other side, so A times T. And I have VF minus V naught still sitting there. Now I want VF by itself, so I bring V naught to the other side, so I get V naught plus AT is VF. Plug my numbers in. V naught is 0, A is 5, T is 3, so I get VF is 15. So I get the same answer. Good. That makes me confident that I did everything correct. So you can see, here's an example where I have multiple choices. I have a choice between multiple answers. Which equation do I want to use? Do I want to use the second equation or the third? Now, personally, especially if you're in a workplace environment, likely you want to use the third equation. And the main reason is if you can solve the equation given only the information that's given to you, using only the information given to you, that's a better way of doing things in general. Because the fear is, let's say you have a big Excel data sheet with all this information, you're maybe building a bridge, or you're calculating dosages in medicine, or whatever the case is. You have an Excel spreadsheet with a whole bunch of data and a whole bunch of equations built into the cells, and you use an answer you got from an equation you had to use, and you use that equation, that answer later on for other calculations. If you mistyped something, if your equation isn't quite right, whatever the case may be, if there's a mistake early in getting one of the early answers, then all of the subsequent answers that use that piece of information will also be wrong. However, if you're only using what's given to you, then if there's a mistake, it's because your employer or the people who gave you the data made a mistake, not you. You did everything right. Or if there is a mistake and it's not because of the data, it's you typed something in wrong somewhere, whatever. But there's very much less probability that you're going to make a mistake given the information to you. So it's up to you how you want to do it. I'm not going to tell you, because either way it should be right. You should calculate part A correct and be able to use that information for part B. It shouldn't be, it's not an excuse, oh, well, I accidentally messed up part A. Well, you shouldn't have messed up part A. But just as advice, because it does happen, everybody's human, if you have the ability to use an equation and not have to use previous answers to solve it, then try it that way. If you're confident in your answers, if you think you did everything correct and you don't see any problem with them, then go ahead and use them to solve for future answers. That's fine. I do it all the time. All right, so I hope this gave some good insight into some stuff. I'll do one more example. Let me do one more example in the vertical direction so we can see how gravity works. All right, so here's a little bonus problem for you. Let's take this problem. A person stands at the edge of a 10-meter high cliff. The person drops a rock and waits for it to hit the ground. How long will that take? Okay, well, first thing, let me go ahead and draw a little picture so we can see what's going on. Here's the cliff. Here's the rock, and the rock is going to be dropped straight down. What do I know? The height of this cliff is 10 meters. Okay. So, as usual, let's write down what we know and what we're looking for. A person stands at the edge of a 10-meter high cliff. The person drops a rock and waits for it to hit the ground. Okay. Well, first of all, we want to know, the question's asking, how long does it take for the rock to go from the top of the cliff to the bottom of the cliff? That's basically what it's asking. So, what do I know? Well, I know how far the rock's going to fall. The distance traveled by the rock is going to be 10 meters. That's the height of the cliff. It goes from the top to the bottom. That's how far it goes. What else do I know? The person drops the rock. Okay, that means something special. They didn't throw it. They didn't throw it up. They didn't throw it down. They just dropped it. That means the initial velocity of this rock was 0. Okay, it just fell out of the hand. So the very, very beginning velocity was 0. What else? I'm looking for t. How long does it take for it to hit the ground? Or how long does it take for it to drop 10 meters? What else do I know? Well, first of all, the question doesn't say anything else specific, but there is something else I know. It's just hidden. One must ask the question, well, wait, if the rock started with no velocity, why does it hit the ground? Why does it move? Why didn't it just sit there? The reason is because gravity is pulling the rock down. And here's our first example where gravity comes into play. How do we consider gravity in our problems? Well, first of all, in future questions, we're going to start having things being able to move in all sorts of directions. So far, when an object moves, it always moves in one direction. It's moving to the right, or it's moving down, or whatever. We're going to have questions where we shoot a cannonball at some angle, so it's both moving left and right and up and down at the same time. That's going to be what's called two-dimensional motion. Right now we're still doing one-dimensional. However, a concept we're going to have to be very, very concerned about is the fact that things that move in the x direction, that means move left and right, that's independent of the object's motion in the y direction, moving up and down. So for instance, when I throw a baseball, let's say I'm a pitcher, I throw the baseball towards the catcher, the baseball moves kind of in an arc. It's moving both from me to the catcher in the x direction, horizontally, but it's also falling because gravity's pulling it down. Well, the motion in the x direction, the horizontal motion, makes no difference to the vertical motion. They're independent of each other. They're both happening at the same time, but one does not affect the other. So what that means is you only ever worry about gravity if you're talking about objects moving up and down. If you have an object that's only moving horizontally, then there's no gravity involved with that. Gravity is only up and down motion. Here we have a rock that's being dropped down to the ground. He's moving downwards. Gravity is involved. Okay. That also tells you why previous questions we haven't worried about gravity. Because nothing was moving up and down. It was all a bike is moving horizontally or a car is moving horizontally. Here, we're moving vertically. So now we have to worry about gravity. Second thing is, okay, if we worry about gravity, how do we do it? What is it? Is it a force? Is it a position, a velocity? What is gravity? For purposes of kinematics, we're going to consider gravity to be an acceleration, because gravity speeds you up in the downward direction. Or if you're moving upwards, it slows you down until it can speed you up downwards. Okay? So when we talk about gravity, it's always as an acceleration. And here's the thing. Gravity is always downwards with a value of 9.8 meters per second squared. Okay? So what does that mean? That means for our data for this problem, we do have an acceleration. And that acceleration is 9.8 meters per second squared downwards. Now, I'm saying downwards here because there might be confusion as we move forward, and so I'm going to do a bunch of examples with it. There might be confusion when we discuss positives and negatives. So, for instance, if a ball is moving to the right, we say it's moving in a positive direction. If it moves to the left, it's moving in a negative direction. Same thing is true of up and down, vertically. If a ball moves upwards, it's moving in a positive direction. If it moves downwards, it's moving in a negative direction. That's a rule. Now here's the thing. Physicists like to break the rules sometimes, because a lot of times if we break the rule a little bit, it makes the math a little easier for us. If you notice, right here, I marked that the distance this rock is going to travel is 10 meters. Technically, it's 10 meters downwards. Okay? So I should keep that in mind. This is a downwards distance. So if I'm going to follow the rule, then when I plug my distance in, I have to plug it in as negative 10. So let's do it this way. Let's go ahead and solve the problem where I allow downwards is negative. Okay? And then I'm going to show you a different way, and it actually happens to be the way I solve problems, which kind of bends the rule so that I don't have to worry about the negatives so often. Okay? Suffice it to say this. If you think you might get confused about when to use positives and negatives, then just follow the rule. If you move up, it's positive stuff. If you move down, it's negative stuff, always. So let's use that rule. What is it I'm looking for? I'm looking for a time. What am I given? X, V naught, and A. So what were our equations again? Let's see, X equals V naught T plus 1/2 AT squared. I also know VF squared is V naught squared plus 2AX. And A is final minus initial over T. All right, so which of these equations can I use? Can I use the first one? I'm looking for T. There's a T in the equation. Do I have X? Yep. Do I have V naught? Yes. Do I have A? Yes. Okay, I could use the first equation. So let's use it. X equals V naught T plus 1/2 AT squared. Plugging my numbers in. X, downwards 10, so negative 10 equals V naught, that's 0, times T. I'm looking for T. Plus 1/2. A, that's downwards 9.8, so negative 9.8 T squared. And now I want to solve this for T. Well, 0 times T, of course, is just 0. So what do I have? I have negative 10 equals 1/2 times negative 9.8 is negative 4.9 T squared. How do I solve this for T? Well, divide the number, move it to the other side. So I divide by negative 4.9. And I get T squared is 10 over 4.9. The negatives cancel. And then I take the square root of both sides. And I get 1.43 seconds. And there we go. So very similar to the previous questions, the only difference being because I'm moving vertically, there was one extra piece of information that was not stated in the problem, but that we just know by our intuition. Since I'm moving in the vertical direction, gravity affects us. How does gravity affect us? By an acceleration. The acceleration is always 9.8 down. Also, you had to remember your negatives everywhere. Because the position, the change of the position, the displacement of my rock was from the top of the cliff to the bottom of the cliff. I moved down, and we're using the rule that any motion that's downwards is negative. So the position is negative, the velocity is negative, the acceleration is negative. If I'm moving up, then those things are positive. So as long as we remembered the negatives where they were supposed to go, plugging my numbers in, I get the fine answer. Now what I want to show you is my little rule bending thing. So, same thing. Again, we have our little cliff. Here's the rock, he's going to fall, and this is 10 meters high. So what do I know? The initial velocity was 0. How far does he travel? 10 meters down. His acceleration, 9.8 down. And the time is what I'm looking for. Now, because I'm a physicist and I don't like complicated math, I like to make it as easy as I can make it. And that's what we're good at. We're good at doing tricks to make math easier. I don't like these negatives everywhere because it's easy to forget a negative somewhere. And if you forget a negative somewhere, everything goes all over the place. So I'm going to say this. Notice all of the motion is in the same direction. Everything is moving down. The distance it's moving is downwards. The acceleration is downwards. There's no upwards velocity or anything like that. So because everything is in the same direction, then let me just pretend like the downward direction is positive. What that really means is, if there was an upwards thing somewhere, he would become negative instead. Because there's nothing, God did not proclamate at the inception of the universe, you must make downward negative. No, humans came up with that rule. We had to distinguish between up and down, and we just happened to choose up to be positive. But that was an arbitrary choice. So that means if we choose the other way, downward positive and upward negative, everything should still come out to be the same thing, because it was arbitrary how we chose it. So, I'll show you how to solve the problem where we don't have all these negatives. And what I'm going to do is I'm going to say, let the downward direction be positive this time. If that's true, how do we solve it? Well, we have the same equation, x equals v naught t plus 1/2 at squared. Plug my numbers in. X, I moved down 10, but down is positive, so that's a positive 10. V naught, 0, plus 1/2 a, downwards 9.8, so he's positive, t squared. By the way, notice I didn't write the t here. That's because it's already 0. 0 times anything is 0, so there's no point in keep writing it. All right, so now simplify things. 10 equals 1/2 of 9.8 is 4.9. T squared. Again, bring 4.9 to the other side. You get t squared is 10 over 4.9. Take the square root. You get t equals 1.43 again. Same answer. Of course it's the same answer. All that happened was all the negatives that are in this problem canceled out. So the fact that I didn't have the negatives here doesn't matter because they canceled. And the reason they all cancel out is because everything was in the same direction. If the problem were slightly different, like the person threw the rock upward with an initial velocity of 5 meters per second, then we're going to run into a problem. Because the V naught for this problem would be an upward velocity. So I'd have to stick a negative there. And now all of a sudden all the negatives don't cancel anymore. So, because of that, when I do these things, in general, the rule is downwards is negative, upwards is positive. But I cheat if everything is moving down and there's nothing up in the problem, then I just pretend down is positive. However, if there is something about the problem which is moving up, then I can't do that trick. So I'll go back to the rule. Now again, if that's confusing, if you're afraid that you're going to get your negatives and positives confused by going back and forth, don't do it that way. Just follow the rule. And the rule says any of these characteristics, any of these variables, if they're in the downward direction, they have a negative sign. And if they're in the upward direction, they have a positive sign. And that's perfectly fine. And the same goes for these other problems, like this bike problem. If the object's moving to the right, which we're assuming the bike moving at 20 meters per second, we just assume it's to the right if it doesn't tell us. So to the right was positive. But notice the acceleration's slowing us down. That means it's pointing to the left. That's why the acceleration has a negative sign, because the acceleration points to the left, and left stuff is negative. Right is positive, left is negative. Over here, down is negative, up is positive. Okay, so it's your choice. You have the freedom. This is the good thing about physics. It's actually pros and cons. It depends on your personality type. Some people consider it a good positive, a good pro, that you have the freedom. There's no one set in stone thing you must follow every time. There's a lot of freedom involved in what we do. You're allowed to make any direction be the positive direction and the opposite the negative one. You don't have to follow the convention. As long as you make it clear to the person who has to read your work, that's why I wrote something like this downwards is negative thing somewhere. That way when someone looks at what you're doing, they understand, oh, okay, so their downward direction is negative. Or over here, I wrote this, downward is positive. If you didn't write that and someone's looking at your work, they're saying, well, wait, where is his negative signs? This stuff's moving down and he's not making it negative. So if you write that, then as long as a person is competent, they're able to understand, okay, so the way they're making their directions, downward is positive here. So I could follow that. That's okay. But if you notice, the answers come out the same. So they're both correct to do. It just depends on what you're most comfortable with. So, there we go. That's how you're going to incorporate gravity into these problems. It's easy. It's just adding an acceleration. That's all it is. And the acceleration is always the same number, downward 9.8, every time. It's never up. It's always downwards, and it's always 9.8. Unless we're on a different planet. But on Earth, it's 9.8. All right, so I hope this has been helpful. Keep checking Canvas for more practice problems, potential quiz or homework or things like that. The next lecture will be on two-dimensional kinematics. So now things can move both left and right and up and down. And we're going to see how do we modify what we've been doing to accommodate that. And you're going to find out it's okay. It's not a big deal. The equations are the same. It's just that we're basically solving two independent problems at the same time. We solve the X stuff over here, and we solve the Y stuff over here. And then we combine it at the end to get a single answer. But both X and Y are done the way you did things here. Okay, so it's not going to change things too much. It's just going to be adding into it the fact that there's two different directions to worry about. Anyway, that's to come. Until next time.